Welcome to Summarize Science. Today, we're looking at how scientists are using artificial intelligence to fight a sneaky parasitic illness called Chagas disease. Chagas disease affects millions of people, often starting with mild or no symptoms, but it can lead to serious heart and digestive problems decades later. A major problem is that the blood tests needed to confirm the disease are limited in many areas where it is most common. But since Chagas often affects the heart, it can leave subtle clues in an electrocardiogram, or ECG. So researchers posed a question: could an AI learn to spot these clues and identify people who should be prioritized for testing? To find out, they organized the George B. Moody PhysioNet Challenge 2025, a massive competition for scientists around the world. They assembled a huge dataset of over 378,000 ECG recordings from 6 different sources to train and test the AI models. This wasn't just any dataset. It included a mix of data with strong labels, confirmed by blood tests, and a much larger amount of data with weak labels from patient self-reports, making it a very realistic challenge. Over 111 teams from academia and industry took on the challenge, submitting more than 1,300 entries. But here's the most interesting part: how they scored the competition. Instead of just checking for overall accuracy, they created a metric based on a real-world constraint: limited testing capacity. The score was based on how many true Chagas cases an algorithm could find if it could only refer the top 5% of its highest-risk predictions for a real test. This brilliantly frames the problem as a triage task. Don't just find the disease, find the people who need our limited resources the most. So, how did the AIs do? The results were very promising, as you can see in this table summarizing the top teams. The best-performing algorithms were significantly better than chance, identifying many true positive cases within that top 5% group. However, the study also uncovered a critical hurdle for medical AI known as generalizability. This graph shows the scores for each team across different, hidden datasets. As you can see, the scores tended to drop, sometimes significantly, when an AI was tested on data from a new patient population or different ECG machines. This tells us that an AI trained in one hospital might not work as well in another, which is a major challenge to solve before these tools can be widely deployed. So let's recap the key points. Scientists organized a global challenge to train AI to screen for Chagas disease using ECGs, a common and low-cost heart test. They used a clever scoring system that mimics the real-world problem of having limited confirmatory tests. The winning algorithms showed that this approach is very promising, potentially finding 3 times more cases than random screening. But the results also highlighted that we need to build more robust AI that can work reliably across diverse groups of people and settings. This research is a huge step forward, providing both a method and a massive public dataset to develop better screening tools that could one day save lives by catching this silent disease early.